Hello everyone. Today me Manharshi Jadeja and my friend Kaushal Doshi we are going to talk about our AI project Sudoku Solver. So the mainly assigned definition was Sudoku solving using CV and AI with an image of Sudoku as an input. So now first understanding of the problem statement. So as per the definition, first we will take the input image input from the user. So from that we will identify the digits from that using some algorithm, and in that after that we will run the logic of Sudoku on that, and at the last we will get the output. So now when we can say that Sudoku is solved, so a puzzle is solved if the squares in each unit are filled with the permutation of the digit 1 to 9. So now the motivation and objective of the problem. So that our motivation is we all know that we are all solving the Sudoku since primitive times, but using the conventional approach. And in a current scenario, the whole world are moving to the technologies. So we want to solve it using the technologies that we are learning in a current time. So there are the mainly three objectives that we think when we get this project definition. That first was we want to make the fastest Sudoku solver. Second, we want to use the legacy of the AI, and the third, we want to enhance our logic. So this is the achieve target that in our previous presentation, these three tasks are our future one. Uh, so at that time we want to implement these all three things. We will fulfill these all three things as we can. That first is grid extraction implementation. Second is digit identification and grid solving implementation, and the third is grid reconstruction implementation. Now let's we see the how output will looks. So now Kaushal, over to you.
Hello, my name is Kaushal Doshi. Now I will be taking over. Next. So here we will see how the flow works in our project. We can see that we have given the path of the input file. So once we will upload the file, it will refine the image like the image given on the right. Next. Now using KNN algorithm, we will get the digits from the image we used previously. So here we can see all the digits printed on the grid form. This is all done because of the pre-processing done previously. And image on the right, we can see that the solution of our Sudoku, which we have provided in the image. Next. In this slide, we will focus on what kinds of problem we have faced in during our project. So first one is we were getting incorrect output. So by this we mean that Sudoku it is a rule that no 1 to 9 digit should be repeated in any row or column, single row or column. So at first when we first got our output, so we saw that there are many numbers repeated in same row or column. So maybe in a row we can see that there are more than one digits, such as 9. 9 is coming two times in same row or column. So that is incorrect. We need to have only one digit and not to be repeated in entire row or column. Next, the next that we faced is the getting image string as 0. So when we fetch the digits from the image, we were getting a string of 0 and a string array of 0. So we didn't get the output as expected. And the last problem that we faced, which was previously demonstrated to our faculty, that he suggested that output took the longer time than expectation. So we need to give output slightly faster than we were getting that time. So we have overcome all of the next. Now project demonstration will be performed by Manar. Over to you, Manar.
Yes, Kausal. So now I will demonstrate. So I have already run our file. So here you can see that from upload image we can upload the image. So here Sudoku 1 image I am uploading here. So it will preview here. So after pressing the next, due to the large data set, it is taking some time. So now here you can say that it is an initial image. So now when I click into a next, it will perform certain task, and at the last it will recognize the digit. So how the algorithm works and how they are proceeding, so that thing will explained by the Kausal through one PDF, that which type of the image processing are happen. So Kausal, you can able to see the PDF.
Yes, Manar, thank you. Now I will be explaining what kind of pre-processing is happening from after getting the after providing image as an input, and the algorithm fetches the digit and putting it into the grid. So the first one of the pre-processing done is the Gaussian blurring of the image. So using Gaussian blurring, the image is blurred in order to reduce the noise and detail it in more depth. Next, next one is the adaptive Gaussian thresholding. In adaptive Gaussian thresholding, we use a Gaussian function to account the different illumination in the different parts of image. As you can see in the image given below, how it works. Now we'll be doing the inversion. So to make the digit and lines white while making the background black. So after getting the output from the adaptive Gaussian, then we will be inverting the image. So the white will be converted into black and black will be converted into white. So inversion happens, and you can get the digits from the image, part of the digit. Next. Now the next one is the dilation. So in dilation, we'll be using sorry, I was disconnected, Manar.
Okay, no problem, Kausal. You can continue.
Now the next one is the dilation. So dilation is used to fill up the cracks in the image. So here we can see that there is a plus shaped 3x3 kernel to fill out any cracks in the board lines and thicken the board lines. Here you can see the how it is uh, thickened. Okay, next. Now the next one is the flood filling. Since the board is probably the largest blob, aka also known as the connected component with the largest area, flood filling from the different seed points and finding all connected components followed by finding the largest flood filled area region will give the board. Next. So the largest board, uh, also known as the board, that is found out after the previous step is called as outer box. So this is the biggest blob that this pre-processing has found. Now eroding the grid little bit to undo the effects of the dilation on the outer box that we did earlier. So it is a kind of refining. Now UF line transform to find all the lines in the detected outer box. So by using UF line transform, we can detect the outer lines, that is the grid. Now merging the related lines. Lines found by the UF transform are that are close to each other are fused together. Finding the extreme lines, we find the border lines by choosing the nearest line from the top with the slope almost zero as the upper edge. The nearest line from the bottom with slope almost zero as the lower edge. The nearest line from the left from the slope almost infinity as the left edge, and the nearest line from the right with the slope almost infinity as the right edge. So this is what it means as it shows in the image. So finding the extreme lines of the board. Now finding the four intersection points. The four intersection points of these line are found and plotted along the lines. So the four corners of the board are being plotted by a bold point. Next, warping perspective. We find the perspective matrix using the endpoints, correct the perspective and crop the board out of the original image. So it uses the border of that bold points that we have found earlier. Now thresholding and inverting the grid. The cropped image from the previous step is adaptive thresholded and inverted. So here we can see a combination of all of the above pre-processing. Now slicing the grid into 81 slices, that is 9 cross 9, to get images of each of the single cell of the Sudoku board. One example is shown below for the fetching the number 6 from the image. This is how it looks. Black filling and centering the number. Any white patches other than the number are removed by flood filling with black from the outer layer points as seeds. Then approximate bounding box of the number is found and centered in the image. So it is kind of a refined number 6. Now finding the next pre-processing.
So this is the all about the pre-processing. Thank you, Kaushal, to explain us
Now
that.
over to you, Manhar.
Yeah, Kaushal. So I'm thankful to you that to explain us the how image will proceed. So after the image processing, we will get the digit that identify the algorithm. So here we are using, as we said, that we are using the KNN. So we are getting some less accuracy for that. Some of the digit are repeating that like 7 and 9. So here we can change if we find any wrong digit. So here I am changing. So after the changing, when I'll click to the reveal solution, it will give the solution of the Sudoku. So this is the all about the Sudoku solver that we made while we are learning the AI subject. So thank you.